Hello everyone, this is Adnan. Welcome to Chemistry with Adnan. In this lesson, we will be covering 2.3 IGCSE Chemistry 0620. And this topic has four subtopics, two for core and two for extended. And we will be covering all of them in this lesson. So the first one is define isotopes as different atoms of the same element that have the same number of protons but different number of neutrons. Okay, as the word isotopes is explained in this statement, let us talk about this more. So isotopes, let's say we have hydrogen. We have two atoms of hydrogen, for example. We have and in one of these hydrogens, we have only one proton in the nucleus, and in the other one, we have one proton and one neutron, right? And let's say we have a third hydrogen atom in which we have one proton and two neutrons. So what is similar between these three is the number of protons, because as we have explained it earlier, that it is the number of protons that define an atom, and which gives identity to an atom. So you cannot change a number of protons on an atom. If you change the number of protons, it means that the atom changes, right? So what is different? It is the number of protons, the number of neutrons that are different. So in this hydrogen, we have only one proton and zero neutrons. And in the second one, we have one proton and we have one neutron. And here we have one proton and we have two neutrons. So isotopes are the atoms of the same element that have the same number of protons, as you can see, but they have different number of neutrons. This is how we define isotopes. Isotopes can also be defined as atoms with the same same atomic number, which is the same as the number of protons, atomic number, but different atomic mass, but different atomic mass. Okay. So these are the two definitions of isotopes, and most of the elements on the periodic table, they have isotopes. So now we move on to the second topic, which states that interpret the use and use symbols for atoms. Okay, so I think we have talked about this before, but let's talk about it in more detail here. So how do you represent an atom? The standard notation for representing an atom is, you put a symbol, you write a symbol, and then at the bottom left, this will represent the number of protons. This is atomic number, right? This is atomic number, and at the top left we write its atomic mass. So on the periodic table, it may be written differently, but when you write it on a paper, so this is how we write it. We have different periodic tables. In some of them, atomic numbers are written at the top, atomic masses are written at the bottom, like for example carbon, so 6 and 12. In another periodic table you will find it like this, that 6 will be at the bottom and 12 will be at the top. But this is basically the standard notation. This is how we should be writing or denoting an atom, right? So if it has a negative charge, for example for chlorine, so this chlorine 17 and atomic mass 35, and with one negative charge, it means that it has 18 electrons, because it has gained one, right? We have already talked about this in our previous lessons. You can watch those videos. So this is basically this is how we write, or we denote atoms with their symbols, their proton numbers, and their mass numbers. Now we move on to the extended, and the topic it state that isotopes of the same element have the same chemical properties because they have the same number of electrons and therefore the same electronic configuration. Yes. So I gave examples of uh, three hydrogen isotopes. So let us talk about these again. So this is hydrogen 1 1, this is hydrogen 1 2, and this is hydrogen 1 3. So why the numbers at the top left are different? Because these are the atomic masses, right? And why the numbers are the same at the bottom left? These are the atomic numbers, and they must be the same for the same atom. Okay. So now chemical properties depend on electrons in the valence shell, outermost electrons, outermost outermost electrons, their number, that how many electrons are there in an atom, and the atomic radius. So these most of the times chemical properties of an element depends on these two properties, that how many outer shell electrons are there and what is their distance from the nucleus, atomic radius. So for isotopes, they have same chemical properties because they are different. uh, you know uh, the difference arises from the nucleus, right? It is the number of neutrons that are different in these atoms. So the number of neutrons, they don't influence chemical properties, right? So chemical properties of an element, they have nothing to do with the nucleus, remember that. So that is why chemical properties for the isotopes of the same element, they will be the same. Physical properties, on the other hand, they can be different because since mass is changing, so physical properties may change a bit. So this is what you need to understand here, that isotopes, they have isotopes of the same element, they have same chemical properties. All right, and also they have the same electronic structure because in all of these three hydrogens, we have one electron. So let me just quickly draw their structure. So the electronic structure for this hydrogen one will be one proton, and that's one electron that is revolving around the nucleus. So now we have the second one where we have one proton and one neutron, and we have one electron revolving around the nucleus. And for this one, which is called hydrogen 3, we have one proton and two neutrons, and one electron is revolving around the nucleus. So you can see here that the atomic radius is the same, the number of electrons in the outer shells, they are the same. So that is why they will have same chemical properties. And you can see that what is different among these elements, it is the nucleus that is different. Okay, so I think we have talked enough about this topic, and now we move on to the last one, which is calculate the relative atomic mass of an element from the relative masses and abundances of its isotopes. Okay, so this is a very interesting topic, and we usually see this on the exam. So you will be given a data. For example, carbon has two isotopes. So let me just quickly write the question. So carbon has two isotopes, carbon 14. Carbon 14, this is the atomic mass, okay, 14, and with abundance, and its abundance is 20%. And carbon 12, that is another isotope that has the atomic mass of 12. Carbon 12 with abundance, with abundance, uh, 20%. This is 80%, right? And calculate the relative atomic mass of carbon. Calculate the relative atomic mass of carbon. So this is basically, yeah, this is how the question will be structured. You will be given the mass and their percentages, right? So for carbon 14, the abundance is 20%. Let me use the same color here, 20%. And for carbon 12, the abundance is 80%. So how do we solve this now? We use a formula, isotope 1 mass times abundance plus isotope 2 second, or isotope 2 mass of isotope 2 times its abundance. And if more isotopes are given, so you can add them here. And but now we have only 2, so we are writing this formula accordingly, divided by 100, right? So now let us put values here. So isotope 1, carbon 14. So I'm gonna write 14 times its abundance, which is 20. So plus isotope 2 mass is 12 times its abundance, which is 80, and I divided by 100, right? And when I solve this, so the answer is okay, 1240 divided by 100, I get 12.4, right? So this is the answer. So this is how we solve these questions. And this will be all for today. 2.3 Isotopes, IGCSE Chemistry 0620. I also provide one-on-one online lessons. If you are interested, you can fill out the Google form given in the description, and you can also join my free community, high school community, on school.com, skool.com. The link is given in the description, where I give free lessons once a month. And you can also subscribe to my premium package on school community, which offers 4 lessons per month, right? And there are other packages as well which you can choose. It is a very interesting place for discussions and answering questions and all the information related to exams. So you should check it out. So all right, this will be all. I'll see you in the next one. Take care. Goodbye.